So here we are on day 2 or day 3, whatever it is. We've got all of our parts mounted in the chassis. We've mounted in our rectifier, our filter capacitors, our potentiometers, input, output jacks, our 3 tubes, fuse holder, what have you, IEC, power inlet, and our terminal strips where we're going to do all the wiring from. This will be a jumping off point from the sockets to the pots. We're also going to mount a terminal strip on these potentiometers themselves, solder these on, one here and then a 3-piece guy over here. And we're kind of doing this on the fly. We have a general idea of like what the layout in my mind. I have an idea of what the layout's going to look like, how this is all going to work. After you do this long enough, I guess you can kind of just build things in your head, and you can save yourself some time, just kind of remembering how you want it all to fit together in your mind, and then just kind of referring back to that mental image when you're kind of putting everything together. So we're just going to freehand this whole thing, and really that's all there is to it. So we've got our resistors and capacitors and all of our parts, so I'm just going to start pretty much going to town on it. And I usually do, I should say this, I usually do just in terms of order. I usually wire up the power supply first, and then I test it to make sure that there's nothing funky going on there, that we're getting the right voltages that we want. And once that's all sorted out, I go through the preamp in a pedal like this, or an amplifier pedal, whatever you call it, a pedal fire. I'm going to use that pedal fire. Yeah, I start with the cathodes, and then I do the plates and then the grids. Reason being is I like, obviously, the grids to be, those are the antennas of the amplifier, so to speak. The plates being the transmitter, somewhat the cathodes are as well. But you want the grids, the antennas, to sort of be up in the air and routed in a way where they're kind of not coupling with any of the other areas of this, or circuit areas in the amplifier. So really, and this is interesting stuff here, there is a bit of maybe what some people would refer to as black magic when you're wiring up an amplifier, and why you may build a Marshall clone and build it into a Fender chassis, and you're like, man, this just doesn't sound right. RF and coupling is real, and there'll be points where wires that are, or components that are next to one another, do interface. There is a little bit of crosstalk. Now these can be reinforcing, or they could be canceling. And obviously if you have a reinforcing signal from a further stage reinforcing back to a prior stage, that's what we call feedback, right? It's a positive loop. If that's canceling, has a tendency to be negative feedback, and it quiets the signal down. So that's something you'd find in a lot of power amps to try to control the excursion of the power amp, is that the more signal it generates, the more feedback in a negative sense it brings back to the amplifier, padding down the signal in a sense. So when you're building an amplifier, you're really trying to take advantage of those sort of phenomenon, these electromagnetic phenomenon that are present, well, really everywhere. I mean, we're literally bathed in it. So you would want components to be placed in areas where you think synergy is going to be appropriate and complementary, and where sort of negative symmetry, cancellation, is going to help you as well to cut out frequencies you don't want. High end that may result in parasitics, which are just basically ultra high frequencies that are present in large quantities on your signal that you can't hear, but the tube is spending a lot, or the circuit is spending a lot of its energy dealing with. So it tends to make the circuit perform poorly at audible frequencies, as it's basically involved heavily in frequencies that you can't even hear. So sometimes negative feedback inside of a localized area of a circuit is helpful in reducing those sort of parasitics, or to bring down, let's say, high end, or you can use positive reinforcement or positive feedback to bring up high end And all these things are going to take place whether you like it or not. I mean, you can't eliminate it. So you better work within those parameters and within what, sort of the universe has dictated you're going to have to deal with. So that's why you'll find a lot of amplifiers, their signature sounds are not so much a result of what capacitor was connected to what resistor, connected to where. That's definitely part of it. But a good deal of it is related to exactly where that component is, where the wires are feeding it, what's next to it, how long is that wire, is it next to something positive or negative reinforcing, what's the EMF signature inside the amplifier, where's the ground plane, what does that look like. All those things really determine, I think, to an equal extent each part, as would be just the values you've chosen for your cathode resistors and capacitors. So anyway, that's enough of that sort of stuff. Maybe we could talk about that another day, but that's getting into like quantum amplification maybe. So I'm going to start wiring this thing up. I'm going to turn on my soldering iron, and I'm just going to go to town on the power amp. So yeah, I'll keep checking in as we make progress.